take some clicks of them. Take some pictures while they are watching the session.
So, all right, I'm going to take some pictures and send them.
Take with a student. Take with a student. Take with a student.
Sorry, I can't understand.
Ma'am, students are watching. No, take from the back side with the students. Front side and back side with children's. Okay. Please, can we start now, ma'am?
Sure, yes, please.
Hemanji, please go ahead. Yeah. You can see the PPT now?
Yes, we can. Yes.
So children can see the PPT. Great, great. So we are going to start the event in few minutes. Not in few minutes, within 60 seconds. So yeah, Hemanji, please go ahead. So ma'am, this is the program we are conducting all over the world, and this is the country number 75. And this is something called Antariksh Gyaan Abhiyaan that we are doing right now in Argentina, right? So during this event, we are going to talk about satellite, different types of satellite, different types of rocket systems, and how a student can think of designing such small scale satellites. So our guest, Mr. Hemant ji, Engineer Hemant Mehta ji, is going to explain you the entire things, how a children can think of making such, those things. Okay, ma'am? Yeah, Hemant ji, please go ahead. You can go ahead. Okay. Okay.
Okay, I'm audible, right? So let's start with the session. Okay, so we are going to see the basic introduction of the satellites. So in the today's session, we are going to cover these 4 points. What is the satellites? We'll try to understand why do the satellites revolve, and then we'll see different types of orbits, which is the major portion of this session. And the last, we are going to study different components of a satellite. So if we think of making a satellite, what are all the components? What are their functions? So that we can build our own satellite. So let's start with this. So basically, we'll start with the definition as what is a satellite. So any object in the space that orbits or moves around a bigger body, a smaller body which is moving around a bigger body, can be called as a satellite. So we have 2 kinds of satellites, natural and artificial. So natural are nothing but the moons. So like our Earth has 1 moon. There is a 1 body which is revolving around the Earth. So we'll say that Earth has 1 moon. So if I talk about Saturn, so there are more than 10 bodies which are revolving around the Saturn. So I'll say that Saturn has more than 10 moons and so on. So those are natural satellites. So all the moons are nothing but natural satellites. Okay. And artificial satellites are one which we build. This satellites and then we send them. So those are also going to revolve around some of the planets or some of the natural moons. Okay, so those also will be called as satellite. But since we are building it, therefore we call it as artificial satellite. So the major, the entire session is going to be about artificial satellite. So before starting, we'll study certain basics. Certain basics about the satellite. We'll try to understand why the path is circular, or to be much more precise, elliptical. Circle is a special case of ellipse. So why the orbit is not square or hexagonal or pentagonal or any random shape. Why it is only circular. This is what we'll try to understand. At the same time, we'll try to understand what are the forces which are acting on this particular satellite or any of the natural moons or artificial moons, or per se all the planets also in the solar system. So, and all are revolving in the circular or elliptical orbits. So we'll try to understand why that also. Okay. So first, let us try to understand. So be it an artificial satellite or a natural satellite or the planets. Okay, you must have studied the basic physics. I'll just again revise those basic physics over here. So any body which is performing a circular motion, okay, requires a centripetal force. That is nothing but center seeking force. If there is no centripetal force, the body will not be able to perform a circular motion. So if I'm saying that all the planets are moving in the circular orbit, all the satellites are moving in the circular orbit, which means to perform the circular motion, they require centripetal force. Okay, we have studied certain amount of basic physics, I guess. So we require centripetal force. So that required centripetal force is provided by the gravitational force. Suppose an artificial satellite is revolving around the moon, then moon will provide that centripetal. Moon's gravity will provide centripetal force. Or suppose the satellite is moving around the Earth, then the Earth's gravitational force is going to provide the required centripetal force. So one force I've shown over here, which is the gravitational force, which is nothing but the centripetal force required for circular motion.
हेमंत जी थोड़ा सा स्लो जाइएगा क्योंकि यहाँ के जो बच्चे हैं ना उनको इंग्लिश में थोड़ी दिक्कत है.
They are saying they are not able to
थोड़ा सा स्लो जाइएगा क्योंकि उनको इंग्लिश जो है ना थोड़ा सा वीक रहता है उनका. अर्जेंटीना है ना.
में कोई इश्यू नहीं है, बट वो यहाँ पर बोल रहे कि they are not able to hear me, ऐसा बोल.
Not able to hear me. Ma'am, can you hear me now? Hello. Alicia, ma'am, can you hear me?
Yes,
Can you
we
please?
can hear you.
हाँ, you can hear. हाँ हेमंत जी वो सुन पा रहे हैं आपको. खाली क्या कीजिए ना थोड़ा स्लो बोलिएगा ना क्योंकि अर्जेंटीना की जो भाषा है ना वो थोड़ी अलग है. इंग्लिश नहीं है प्योर.
Hey, Hemant, but we can understand. We can
Yeah, ma'am.
understand your
Yeah, we are
presentation, but
talking
there are
about
some issues.
we are talking about force of gravitation that children already know about it. That the force of gravitation which acts, which pull the object towards the earth. So that is what we are talking about right now. So हेमंत जी थोड़ा स्लो जाएंगे ना तो इनको समझ में आएगा. ठीक है. ठीक है. बता दीजिए. जाइए हेमंत जी आप शुरू कीजिए.
हाँ हाँ.
Estoy poniendo mejor cara de porque funciona.
Basic physics says that if a
Please,
body has
let's be
to perform
respectful.
circular motion, it requires centripetal force. That centripetal force is provided by gravity in the case of solar systems or in the case of artificial or natural satellites. This is what I've highlighted over here. But as per the Newton's third law, to every action there is equal, opposite, and instantaneous reaction. So if there is an action force, there has to be a reaction force. So that we call it as in basic physics as centrifugal force. Now these are equal and opposite because of which this get balances. It neither gets attracted towards the earth or falls onto the earth, or neither moves away from the earth. This is what I was trying to explain. So there is a gravity force, which is the required force for the circular motion. And then as per the Newton's third law, there is an opposite force, which we call it as centrifugal force, which is balancing it, and not because of which this satellite is not falling onto the earth while in motion. Okay. Now, if I want to find out velocity at any point, what we do is we draw a tangent. What we do is we draw a tangent at that particular point. So that gives me the direction of velocity. So this is what I've shown over here. At any particular point on the circle, if I draw a tangent, I get the direction of velocity. Now here is what the basic question comes, which I started with. Why the orbits are circular or elliptical? And why not hexagon, square, or pentagon? Okay, so that is now what I'm going to answer now. We'll try to understand Why only circular or elliptical? So, if suppose if this particular object is applying force on it, and if it continuously applies force, what is going to happen is it is going to lose the energy. Okay. So if I talk about solar system, all the planets are revolving around the sun because of the gravity of the sun. So suppose if sun is applying the gravitational force continuously, then it is going to lose the energy. So after a certain amount of years, it will not have the same energy. Because of which, what will happen is the planets will fall into the sun. But this has never happened for billions of years. What does it imply? It implies that no energy is lost in applying this force. So how is it possible? So again, this is where the physics comes. Okay, the basic physics formula for work done is force into displacement, but that is the special case. Actually, as per trigonometry, okay, work done is force into displacement into cos of theta. That is this gravity force, this velocity and angle between them. So work done is nothing but force, this force into displacement into cosine of this angle. Okay, cosine of the angle theta. This is what work done is as per physics. So if this angle is 90 degrees, then as per the trigonometry, cos of 90 degrees is 0. Okay, so cos 90 is 0. So now if I put into the formula, force into displacement into cos of 90 degrees. So what happens is it becomes 0. Even if the force was non-zero, even if the displacement was non-zero, still the product what we got, still the work done what we got is 0. And if the work is not done, what is the definition of energy is capacity to do work. So if the work done is 0, then the energy lost is 0. This happens only when this angle is 90 degrees. And circle is the only figure when your displacement and the force is going to have 90 degree with each other. Why? Because velocity is tangential. How do you find out velocity? By drawing a tangent at every point. So at each and every point, what is going to happen is, okay, the angle between the force and the displacement is going to be 90 degree. And cosine of 90 degree is 0. So that is how work done becomes 0. Hence the energy spent becomes 0. Hence, okay, the planets don't fall into the sun. Similarly, okay, the planets don't fall, the satellites don't fall into the planets. The same reason. That is the reason why the orbits are circular or elliptical. I hope I'm able to explain you why the orbits are circular only, not square, hexagon or pentagon. Next, we are going to see types of satellites. Okay, so basically we are talking about artificial satellites, and basically artificial satellites are of two types. Okay, one are called as polar synchronous and one are called as geosynchronous. Okay, polar synchronous means they will be in sync with the poles. That is, they will always go from North Pole to South Pole or South Pole to North Pole. So suppose if I take this, and suppose this is my North Pole and this is my South Pole, then the polar synchronous satellites are going to move like this, North Pole to South Pole or South Pole to North Pole. Okay. So these types of satellites are called as polar synchronous. They will always be moving from North Pole to South Pole or South Pole to North Pole. Okay, such satellites are called as polar synchronous. Next type of satellites are called as geosynchronous. Geo means geographical location on a globe will always remain on one particular geographical location. Okay, let us try to understand with a very good simulation. You will understand this more properly. So see here, initially this satellite is on this African continent. Okay. Now just observe, wherever the African continent goes, this satellite will always remain above the African continent, which means this is geosynchronous satellite. Okay, it will always remain above one particular geographical location. So see, wherever Africa is going, it is always above the Africa. Okay, such satellites are called as geosynchronous satellites. Always above one particular geographical location. I just want you guys to pay attention on this. We are going to discuss this. The distance between this satellite and the Earth is large. Now the next satellite is going to come. That is the polar synchronous. Now this satellite, this is what I was explaining you. This is moving from North Pole to South Pole, North Pole to South Pole. This particular satellite is polar synchronous satellite. Now observe the difference between the both. This is rotating at a very low speed, whereas this is rotating at a very high speed. First, and second thing which you will be able to observe is this is at a large distance from the Earth, and this is at a smaller distance from the Earth. See, you can observe this. This is at a very smaller distance from the Earth. Okay, whereas this geosynchronous was at a very large distance from the Earth. Keep this in mind. In the next slide, we'll try to understand. And next thing, one more which you should observe in this animation is this is moving at a very high speed, whereas the geosynchronous one is moving at a very low speed. We'll discuss this. You observe the animation. So this is your polar synchronous and this is your geosynchronous satellite. I hope with the animation you have got the good idea about polar synchronous, how does the polar synchronous revolve, and what is this geosynchronous. You just pay attention on this. We are going to discuss the speed and the distance. So this is going to be the major portion, and here we are going to discuss. This is going to be the major portion of our particular session today. So basically, there are more than three that also we are going to see, but basically there are three types of orbits which we use for artificial satellites with respect to Earth. Those are GEO, that is geostationary orbit, MEO, that is medium Earth orbit, and LEO, that is low Earth orbit. So let us understand one by one. The first is LEO. Okay, so which are called as low Earth orbit. which regions do we call it as low Earth orbit? So the regions which are at a distance of 160 kilometers to 2000 kilometers from the Earth's surface. Okay, those are called as low Earth orbit. Now, if I talk about International Space Station, so this International Space Station is roughly about 440 kilometers from the Earth's surface. Okay, it means it is lying in this range, 440 kilometers, which means the International Space Station is in the Leo orbit. Okay, it is in the Leo orbit, that is low Earth orbit. So apart, there are a lot of satellites which are revolving in the low Earth orbit. So what are the use of the satellites which are in the low Earth orbit? So the very first thing you try to understand is basically the one which are in the low Earth orbit are always polar synchronous, which means they'll be near to the Earth, which we saw in the animation, and they will be revolving at a very high speed. So within 24 hours, okay, they'll be able to cover, that is revolve around the Earth for more than 5 to 6 times, which the polar synchronous satellites. So again, the satellites which are in the Leo orbit are generally polar synchronous. So in 24 hours, they are going to go around the Earth for more than 5 times in a day. So what they are going to do basically? So they are going to do basically weather forecasting, satellite phone communication, oceanography, for defense purposes. Say, for example, if one country wants to snoop on the another country. Say, for example, there is a war between, say, India and, say, Pakistan. Suppose the Indian forces wants to know the position of the Pakistan army, where they are basically, how many tanks are there and how many infantry, whatever, how many guns, cannons are there, and whatever I want to know, suppose. So what I can do is, I can use my polar synchronous satellites, okay, and make them move around that region. And they'll capture the photos and they'll send me, from which I'll be able to understand, okay, the positions. So that is also one of the, okay, say applications of the satellites which are in the Leo orbit. Okay. Apart from that, I said oceanography is there. Then finding the minerals in the lithosphere of any planet or on any moon, say. Okay. Those are also the things of polar synchronous satellites. Next is Neo orbit. Okay, before going to this, one more point I've written over here, which you can see, satellite revolving in this region has minimum time period of 1.5 hours. Now, why have I written this? So this is where I'm going to explain you the speed. So if you just remember law of gravitation in physics, the law of gravitation in physics says that the gravity force is directly proportional to product of the masses and inversely proportional to distance between them. What does it mean? It means that as the distance between the two bodies increases, the gravity force is going to decrease. Okay, and it is going to decrease at the rate of square. This is what it means. Okay, so now this polar synchronous satellites or the satellites which are revolving in Leo orbit are near to the Earth, And if you talk about geo orbit, okay, so if you just remember that animation, so geostationary satellite was at a very high distance as compared to polar synchronous. Now, since geosynchronous was at a very large distance, so as per Newton's law of gravity, as distance increases, gravitational force decreases. Therefore, less amount of force was acting on the geostationary satellite. Whereas the polar synchronous satellite or the satellites which are in the Leo orbit, those are near, so distance is less. Hence, as per law of gravity, the gravity force will be more on the satellites in Leo orbit as compared to the geo orbit or say geosynchronous satellites. Okay. Since less amount of force was acting on geosynchronous satellite as it was on the large distance, hence it was revolving around the earth at a smaller speed. Whereas the polar synchronous satellite was near to the earth's surface. Therefore, more amount of gravity was acting on the polar synchronous satellite. Therefore, it was revolving at a very high speed, which you saw in the animation. Okay. Now, let's go to next, that is middle Earth orbit. So, that generally ranges from 2000 to 35,000 kilometers from the Earth's surface. So, what is the use? So, generally, GPS navigation. So, we go on to the Google Maps and we go for the directions. I want to go from one place to another place. So, you use the Google Maps, right? Basically, so that GPS, okay, those GPS satellites are placed in the middle Earth orbit. So next, what basically I've written over here is that typically requires 24 satellites to cover the entire Earth. We'll see that, okay, after the next slide. So next is geo, okay, stationary orbit or geosynchronous orbit. So it is about 35,000 kilometers from the Earth's surface. To be precise, 35,786 kilometers from the Earth's surface. So basically it is used for broadcasting. So now what is happening is the broadcasting one. So now I'm in this part of the world, okay, from where I'm using my internet. The signals are going to this satellite, and then the signals are passed on to this satellite. Then the signals are passed to this satellite, and you guys are there in this part of the world, and you are receiving this particular signal, because of which you are able to hear me and see me now. You are able to see my presentation. You are able to hear me and see me. This is happening because of this geosynchronous satellites or the broadcasting. This is the live broadcasting. Now this is at 35,000 kilometers from the Earth's surface. All the satellites are at 35,000 kilometers from the Earth's surface. So how much distance it is covering? This 35,000 plus almost this 35,000, that is 70,000. Say almost this, say 40,000. And then this 35,000. So it is covering more than 1.5 lakh kilometers still you are able to hear me in the real time. Why like this? Because the signals, whichever signals which are getting transmitted, these signals are getting transmitted in the form of electromagnetic waves. And these electromagnetic waves, they travel at the speed of light. And what is the speed of light? 3 into 10 raised to 5 kilometers. That is 3 lakh kilometers per second. So they can travel 3 lakh kilometers in 1 second, and this was less than 3 lakh. Therefore, you are able to see me and hear me in real time. And this is happening only because of this geosynchronous satellite. Okay. Now let us understand one more thing about, let us try to understand basic difference between geosynchronous and geostationary. So you can see this something is written over here. So concentrate on any of the letter over here. Now our earth is not at this axis. Earth is tilted. Earth is tilted at 23.2 degrees. It is not like this. It is not rotating like this. Okay. Earth is tilted like this and it is rotating like this. Now, because of tilt, what has happened is, now this particular thing is at this point. Now when it is rotating, when my earth is rotating, okay. So because of the tilt, when it rotates, it is not in the same horizontal plane. At this point it is here, but after rotation, it is above this horizontal plane. Okay. This O. Now this is tilted. Now when I revolve it, it is not in the same horizontal plane. It is little bit above. Now you can see this O is up and it is not here, which means it is not lying in the same horizontal plane, which means it is not going to revolve like this. It has to revolve like this. Okay, my satellite will not revolve in the same horizontal plane. It has to revolve something like this in an inclined plane. Okay, my satellite has to revolve in the inclined plane and not in the horizontal plane. Okay, but the point which are on the equator will always remain in the same plane. Therefore, we call it as geostationary. Now, what is geosynchronous? So this is what I said. At one point, this O is down, and at the other point, the O is up, which means I will have to adjust my height. Okay. So if I'm adjusting the height while revolving, then it is called as geosynchronous. This is the basic difference between geosynchronous and geostationary. So whichever countries are above or below the equator, okay, they will follow geosynchronous. And the countries which are lying on equator, they are going to follow geostationary. I hope I'm able to explain you. Let's move to the next slide. Okay, now let us understand this fourth type of orbit, which is less used, which is called as highly elliptical orbit. So I said circle is a special case of ellipse. If you study a bit of mathematics, part called as conic section, okay, there you will be able to understand why I'm saying that circle is a special case of ellipse. So now if you take a circle and if you press the circle, what will happen is from other sides it will bulge out. If the circle is like this and if I'm pressing, it is going to bulge out something like this. So the shape which it gets, it's called as ellipse. So this ellipse is what I've shown over here. So now we are talking about elliptical orbit. So three types of the basic orbits were LEO, that is low Earth orbit, MEO, that is middle Earth orbit, and GEO, that is geosynchronous orbit. Now the next is highly elliptical orbit. So now countries which are near to the North Pole. Okay, near the South Pole, there is Antarctica. There is, okay, the country is not, no one is living over there. So I'm talking about North Pole. So the countries which are near to the North Pole or which are having certain area which is near to the North Pole, they directly get affected with the amount of snow, okay, which is getting deposited during the winters or which is melting during the summers. Now, if I'm in the circular orbit, I'm going to remain on the North Pole or the South Pole only for certain moment. Okay, let me show once again. So if I'm moving like this, okay, so this is my North Pole. I'm spending very less amount of time on the North Pole and maximum time is away from the North Pole. I don't want that. Why? Because I want to do a proper weather forecasting. So my satellite has to remain maximum amount of time near the North Pole and not away from the North. That is why this countries, what they do is, they do not go for LEO, MEO or GEO. Instead, they go for an highly elliptical orbit. So advantages which you can clearly see in this particular, okay, diagram. For most of its time, for most of its journey, it is always near the North Pole. For most of its journey, it is near the North Pole. And only for less amount of its journey, it is near the South Pole. So the problem got solved by using this highly elliptical orbit. Okay, their problem got solved. Now, maximum amount of time it will remain near the North Pole, which will help in giving a proper idea about the deposition or melting of snow. Okay, and hence weather forecasting. Let's move on to next. Now, geosynchronous orbit, geotransfer orbit. Or we can just say a transfer orbit. So we'll try to understand first what is a transfer orbit, and then we'll see what is a, okay, geotransfer orbit. Now, what is a transfer orbit? Transfer orbit is a temporary orbit. Okay, transfer orbit is a temporary orbit where my satellite is going to revolve before moving to the portion where it wanted to go. So suppose there is a satellite which is revolving in the LEO orbit, and from the LEO orbit it wants to go in the geostationary orbit. It wants to go in this geostationary orbit. So what it does is,
हेमंत जी, उनके
बोलिए
पास थोड़ा समय की कमी है, इसलिए प्रेजेंटेशन यहीं पर छोड़ दीजिए, ठीक है ना? वो बच्चे जाना चाह रहे हैं,
चलेगा चलेगा, कोई
यहीं पर कंक्लूड कर दीजिए, मैं उनसे बात कर लेता हूँ 1 मिनट, मैं ही बात कर लेता हूँ.
ठीक
हाँ, हेलो एवरीबॉडी, कैन यू लिसन मी नाउ? मैम, आर यू एबल टू सी मी? प्रेजेंटेशन बंद कर दीजिए ना.
हाँ,
हेलो मैम, हेलो मैम, कैन यू सी मी नाउ? हेलो मैम, कैन यू सी मी? Hello.
Okay, thank you very much for your presentation. Unfortunately, we had some issues with the sound. We couldn't really understand exactly what you were saying. We appreciate your effort. We know that you tried to read slowly and carefully, but it was really very hard for us to follow. Anyway, I think that the slides were interesting with the information that we are going to surely take advantage of.
Yeah, ma'am. I will show you some childrens. Just see the children. Some childrens are
Yeah,
here. Just
they're here. They
one
were
minute.
all very attentive. They were all an effort. So thank you very
One.
much.
Thank you, ma'am. Thank you so much for your time and thanks for everything. Please write down so that we will give the certificate to them. Every student will get a certificate.
Okay. Well, thank you, Heman. It's been a pleasure. Goodbye.
Thank you so much, ma'am. Thank you so much.
Everybody. Thank you. Okay. Bueno, okay, let me just a few words. So I'm going to speak together. First of all,